In this video, we are going to set up an Apache web server. This time, we are going to be using Rocky Linux VM as a Red Hat-based system, so that I can also show you the SELinux context labels related to the HTTP server. Let's start with the installation of the web server package. On a Red Hat-based system, the web server package is called HTTPD. Let's check if it is working. We are going to open a web browser and type the server's IP address here, and we can connect. Let's check the HTTP daemon. So the process is not running by default after installation, and it is disabled. So let's enable it so that it will start automatically after system startup. And start the web server as well. But we still can't reach the web server. Let's check if there is a process listening on TCP port 80. Yes, the HTTP daemon is listening on TCP port 80. So the only thing left which can prevent us from accessing this port is the firewall. Let's check the firewall configuration. And indeed, we don't allow the HTTP service by default. So after this short troubleshooting, we have found out the reason why we can't access the web server. So let's add the HTTP service to the firewall configuration. And I'm gonna add the HTTPS service as well, because later we are going to configure TLS and certificates. So we will also need port 443 and reload the firewall. Now we can access the web server, and we are presented with a test page. Let's check the configuration files of Apache. They are located in etc httpd directory, and the main configuration file is located in the conf directory and called httpd.conf. So let's open this file. As you can see, there are a lot of useful comments here, and we can set a few parameters here. So the server root defines the directory where the web server is looking for configuration files. We don't want to change that. The listen option is pretty self-explanatory. So by default, the web server provides the service on TCP port 80. We can change that here if we want. The other important parameter is the document root. So the web server looks for contents located in this HTML directory. So we can place HTML files here, for example. I'm gonna change this. I have created a simple HTML file in a /web/HTML directory, and I want Apache to display that file for me. And I am also gonna change this directory block. So I want these options for the /web directory. I'm gonna talk about these later a little bit more, but now let's apply the changes and save the file. We can check syntax errors by typing httpd/t and restart the web server. So we can do that with the restart, or the reload works as well, to just reload the configuration files and not stop the process. If we don't know if the service supports the reload of the configuration files, we can say systemctl reload or restart. With this one, we do reload if the service supports, or full restart if it does not. And let's refresh the browser. And nothing changes. The reason why the web server can't render the new index.html file for us is the wrong SELinux context label. In these kind of situations, we can open the audit.log file and check what's wrong. It can be found in /var/log/audit directory, and we should search for the keyword AVC. It stands for access vector cache, and SELinux logs its thing with this keyword. And we have found our file here. So we need to modify the context label of this file and change the default _t type if we want to make sure that it is the reason which prevents us from opening this file. We can put SELinux in a permissive mode temporarily with the set and force 0 command, and refresh the page. And now it is working, but we don't want that, so I will change it back to enforcing mode. We are going to change the context of the /web directory. We can easily find out what the new type should be. We just need to check the default directory. The new type we should set for the new directory is this httpd syscontent t. And the new directory has only the default type. So we could do that with the chcon utility, but that solution wouldn't be persistent and wouldn't survive file system relabel. So we are going to use the semanage and restorecon utility to apply the changes. This is a regular expression here, and this command applies to any files under the web directory and in any subdirectories, depending those subdirectories exist or not. But we are not done yet. As you can see, we still have the default type, so we need to apply relabel on this directory recursively. And now the web server is allowed to read the file and display the contents for us. Now let's move on to VirtualHosts. We are going to configure name-based virtual servers to be exact. So what does this mean? With one server, we can serve many websites. So it is not necessary to set up new web servers for every single website we want to configure. And this example, we are going to configure two virtual hosts. The first step is to configure name resolution. We could do that with local DNS and create an A record for both virtual hosts and assign the same IP address to them, but we won't do that. We will edit the client's etc host file, which takes precedence over DNS by default. So we are going to create two entries here. One for server1.example.com and the other one server2.example.com. Both will be resolved to the same IP address, the IP address of this Rocky VM. Save the file, and to make sure, we can check the etc nswitch.com file, and according to this line, local resolution takes precedence over the DNS server. So we are good to go. Now we need to create two configuration files for both virtual hosts. And we are going to create that in the confd directory. So the first one, server1.example.com.conf. The point here is that it must end with .conf. So we will be listening on TCP port 80, and the two most important option here is the document root. Again, we have to create an index.html for this site in this directory, which has not been created just yet, and the server name. So if you enter the URL in the browser, first the domain name is going to be resolved to the IP address of this Rocky VM, of course, and then Apache reads the HTTP header. And if it finds this name in the HTTP request, it forwards that request to this virtual host. So I'm gonna save this file, create the other file of the second virtual host, and then create the HTML files in this directory. And now restart the web server. And I made a mistake, which I need to correct first. And again, restart the web server. And let's test it with the Kali VM. So server 1 works, and server 2 is working as well. So both sides has been served with the same web server, but see that padlock icon crossed out there? That means that we are using HTTP and sending everything in plain text. Now we will change that and set up certificates. First, we are going to install the mod SSL package. And in the confd directory, a new file called ssl.conf has been created. But we are not going to modify this file. We are going to edit the configuration files of our virtual hosts and change it to port 443. And besides that, we need 3 additional options. With the SSL engine on, we enable SSL, which is TLS, of course. With the SSL certificate file, we specify our certificate, and with the certificate key file, we specify our private key. Now we need to generate them with the OpenSSL utility. I'm gonna open another terminal. So first, we create our private key. And place it to this directory. Next, we create a CSR or certificate signing request. And we have to provide some additional information for the CSR. So normally, a certificate authority has to sign or validate a CSR. But this time, since this is an example, we are going to sign it ourselves and create a so-called self-signed certificate. So now we have the certificate. We put that here with the absolute path. And we have the private key. We need to specify that in this row. Now we are done. Let's restart the web server and test it. As you can see, now we are listening on TCP port 443 as well. So let's open our browser and visit server1.example.com. And we are presented with a warning message because we have a self-signed certificate and the browser couldn't verify its authenticity. We can proceed. We can also take a look at our certificate. These are the informations we have provided before. Next, we will restrict directory access to certain users. First, we create an htpassword file. And create an entry in this file for test user 1, for example. And type in the password. As you can see, this file contains the user and the hash of the password I typed in before. And by the way, this user does not have to exist on the etc passwd file on the Linux host. So this is a separate database. Now we need to modify the directory block in the httpd.conf file, which we want to restrict the access to. We open the httpd.conf file and search for the web directory. The first thing we do is we comment out this require or granted option, and we specify some additional options starting with auth type, which is gonna be basic. We give it some random name, and we specify our recently created HT password file with the out user file option. And lastly, we restrict access to this directory to only users who are defined in this file. And we do that with the require valid user option. Let's save the file, restart the web server and test it. And yes, as we expected, we have to provide our credentials to view the contents of this website. One more thing I want to show is how we can enable home directory access. The first thing we need to do is open the userdir.conf file. And as we can see, this feature is disabled by default, but we're gonna enable it. And we need to specify the directory name within the home directory, which we're gonna use. Let's use this default public HTML directory. We remove the comment before this line and save the file. And next we need to define options for this new directory. So we open the httpd.conf file and I want to highlight this option called indexes. So what should happen if we don't have the index.html file in this directory? So by default, Apache is gonna display the default page and ignore everything else in this directory. With this indexes option, if we don't have the index.html, Apache creates a list of files in the directory. So this is useful if we want to just display the contents of this directory or just download certain files. The follow symlinks option just means that we allow symbolic links. So save the file and restart the web server. And now we create the public HTML directory and some files for testing. And now we need to modify the permissions of our home directory. We are good with the public HTML directory, so everyone has read and execute access to this directory, but only the Rocky user has read and execute permission to the Rocky directory. So we need to change that. We could apply the mode 755 to this directory, but we want to be more precise. So I'm gonna be using the setFacal command. So the Apache user can enter this directory from now on. Let's test it. And it's forbidden. We don't have permission to access this resource. Again, our issue is SELinux related, so for testing purposes, I'm gonna change it to permissive mode. Yes, so the web server creates this nice looking page and we can download our files we would like to. Now I'm gonna change back to enforcing. And it's forbidden again. So we note that we need to modify things with SELinux and we need to enable the boolean called httpd enable homeDirs. And with the -p switch, we make it persistent. So it's gonna survive system reloads. And now it's working again. One last thing I want to show is how we can change ports. By default, we are using port 443 for HTTPS. Let's change that. So we open the ssl.com file. We can listen on multiple ports, so we can add additional lines below this. But I'm gonna change this to port 4488, for example. And also change the configuration of the virtual host as well. And restart the web server. And we get an error message. So let's see what went wrong. Permission denied. Could not bind to address. We are not allowed to use this port basically. And we have to assign the appropriate label to this port with semanage. So let's find out which label does port 443 use by default. It has this HTTP underscore port T type. We need to assign this type to our new port. And restart the service again. No error messages this time. So let's check with the browser. Still not working. Let's check the listening ports. And the web server is listening on the new port. That's a good sign. But again, after some short troubleshooting, the firewall prevents the clients from accessing this new port. So we add this new port to the firewall configuration. And now we can reach this website using the new port. So remember that we also need to change the SELinux label of the new port.